Hi everyone. In this video, we are going to discuss about how to calculate the area of a trapezoid and what is the formula of its area. Now, trapezoid is a name which is most commonly used in the US English. In the British English, it's called trapezium. They both mean the same thing. It's just a special kind of quadrilateral where one pair of opposite sides have to be parallel to each other. Now, in this diagram, I have an example of a trapezoid where the sides AB and CD, they are parallel to each other. And I have made a note of that on the right hand side that DC is parallel to AB. Now we are going to see how to calculate the area of this trapezoid. Right? Now for that, we are going to conveniently divide this trapezoid into three separate polygons. And let's see how that looks. What I have done here is that I have dropped two perpendiculars. One perpendicular from D onto AB and that landed at point E, and another perpendicular from the point C onto AB again and it landed at the point F. And I have denoted that they are perpendicular and they are making right angle with the line AB. So now we can see that the trapezoid has been divided into a triangle, a rectangle and another triangle. Now why this is rectangle? Well, because these two sides are parallel. So let me denote that. So these two sides are parallel and then we have two perpendiculars here. They are also parallel. So these two sides also would be parallel for the rectangle DEFC, or rather for the quadrilateral DEFC. So we have opposite sides are parallel and then again we have the angles also 90 degree, because if these two angles are 90 degree on the parallel side, these other two angles would also be 90 degree. They would also be right angles. So we can clearly see that DEFC, this quadrilateral, is actually a rectangle. So now AED triangle, that's a right triangle, because this angle right here, that is also a right angle. On this side, that is also a right angle. And similarly, the triangle CFB, that is also a right triangle, because this angle right here, that is a right angle. So the area of the trapezoid will be the sum of the areas of the first right triangle plus the area of the rectangle plus the area of the second right triangle. So can we write it like this? Area of the trapezoid ABCD would be equal to the area of the triangle AED plus the area of the rectangle DEFC plus the area of the triangle CFB. Now from the diagram, let's also make a quick note here that since DEFC has been proven to be a rectangle, we can say that DC is equal to EF. So let me make a quick note here that DC is equal to EF and similarly DE is equal to CF. So now let's proceed with the calculation of the areas of these three geometrical shapes. The area of the triangle AED would be half of AE times DE. That is the area of the triangle. So let me enclose that with a parenthesis there. Plus the area of the rectangle would be DE times EF plus the area of the triangle CFB would be half of FB times CF. We know that the area of a triangle is half times base times the height. Now from here, can we write it as half of AE times DE plus, here I'm going to say half of 2 times of DE times EF. I'm just forcefully introducing a half there and then I multiplied by 2, so that becomes 1 again, plus here we can say half of FB times, where we have CF, in place of CF can we write DE, because we know that DE is equal to CF. Alright, now let's proceed with the calculation again. So from here, if we take half times DE as common factors and then let's see what we are left with. So from the first term, we will be left with AE, and then from the second term, we are going to be left with 2 times EF, and then from the third term, we are going to be left with FB. And then from here, can we say this is half times DE times, let's rearrange this little bit. So I'm going to say AE plus EF plus FB plus we have 1 extra EF. So that 1 extra EF can also be written as DC, because DC and EF, they are equal. So the 1 extra EF that we have here, in place of EF, I'm going to write DC. And then from here, can we write it like this? So this is clearly half times DE times, now if you look at this, AE plus EF plus FB, this is nothing but AB. That's the side AB. So if you look at it right here, AE plus EF plus FB, that is equal to AB. So in place of that, now I'm going to write AB plus where we have the DC, I'm going to write DC. And now I'm going to rearrange just a little bit. So you can say this is half times AB plus DC times DE, and then this is nothing but half times sum of the parallel sides times DE is nothing but the distance between the parallel sides. If you can see in the diagram, DE is actually the distance between the parallel side, and that is actually the formula for the area of a trapezoid. Now let's take an example. Suppose we have a trapezoid where AB is parallel to CD, and also we have been provided that AB is equal to 5 centimeter and then CD is equal to 10 centimeter, and the distance between the two parallel sides is equal to, let's say, 6 centimeter. So what would be the area of this trapezoid? Well, then we can say area is equal to half times sum of the parallel sides. So sum of the parallel sides would be 5 plus 10 multiplied by the distance between the parallel sides, that is 6, and since this is area, this would be in centimeter square, and that will be equal to 10 plus 5, 15, 15 times 6, 90, and half of that, that's 45. So the area of this trapezoid is actually 45 centimeter square or 45 square centimeter. We just have to remember that the area of a trapezoid is half times sum of the parallel sides times the distance between the parallel sides. I hope everything made sense. Thank you for watching. See you in the next video.